Welcome to this video series produced by CEP Forensic, which will introduce you to the science of forensic engineering. Understanding moisture migration and the various forces that drive how moisture moves through a building is paramount when investigating the cause of water-related property losses. In this video, we'll examine some key terms related to the building envelope and the ways that moisture damage can occur. The term building envelope covers all the components of the building that separate the interior from the exterior environment. These components generally include the insulation, air barrier, vapor retarder, and various flashings. In addition to these components, a roof membrane or shingles and roof decking are unique to roof assemblies, while exterior cladding, wall sheeting, and windows and doors are unique to exterior walls. Foundations include either damp-proofing or waterproofing, which act as the envelope component applied over the structure. Water losses due to building envelope failures can present themselves in many forms. Moisture damage can become apparent once a sufficient amount of moisture leaks into the interior, is retained by the building materials, and cannot be removed quickly. First signs of moisture damage can present themselves in the forms of stains, wet areas, and mold growth. Certain water losses are apparent, such as roof and basement leakage, while others may be less obvious, such as condensation. Sources of moisture include rain or melting snow, capillary action from liquid or vapor in the ground, air leakage through the building enclosure, and moisture built into the envelope from construction materials. Common damage related to condensation includes staining, mold, frost, icicles, wet areas, water dripping, rot, and odors. Controlling rain entry above grade and groundwater entry from below grade have been the focus of builders and designers for decades. Air leakage and vapor diffusion have received far less attention. The push for energy efficiency has been rapidly evolving construction materials and methods, resulting in tighter buildings. However, these methods, which are meant to perform better energy-wise, are more sensitive to air leakage than older constructions. In the presence of a design flaw or construction defect in a tighter building, moisture that finds its way into an assembly through air leakage may not have the ability to dry out. Air leakage and vapor diffusion commonly occur when temperature gradients across the roof and wall assemblies are high. For example, in winter when a building is heated and summer when a building is air-conditioned. As warm, humid air comes into contact with a cold surface, water forms. The resulting damage is often perceived as water leakage, but is actually condensation. Condensation often develops on window surfaces, but can also form in attics and exterior wall assemblies, causing mold, rot, and structural decay. While condensation can occur in both summer and winter, this phenomenon is more frequent during our cold Canadian winters. Several factors can contribute to the development of condensation within a building. For example, occupancy behaviors, including cooking, breathing, watering plants, and humidifying living spaces, all increase the ambient moisture. Building systems, such as HVAC systems, when poorly maintained or inoperative, or extreme weather events like cold snaps or high outdoor humidity, can also trigger condensation. Gaps or voids in building insulation create cold spots that support condensation. But don't worry, practical solutions for these types of moisture problems exist. When investigating a moisture-related loss, it is important to identify uncontrolled air leakage, thermal bridging, and poor humidity management. The principles of building science, construction materials and practices, and ventilation requirements must be well understood by the investigator to ensure the cause is accurately determined. If you are interested in learning more about the moisture damage and the building envelope, contact our experts or read our articles on the subject.